Hi everyone, Kyle here from Redis Labs. In the next 3 minutes, we're going to go over the basics of active-active geodistribution in Redis Enterprise. First, let's talk about a problem that active-active solves. So, let's say you have two data centers. One data center is in San Francisco, and one is in San Jose. For those not familiar with this part of the US, these two cities are about 80 kilometers apart. Users on your mobile shopping app are routed to the data center with the lowest latency. So, let's imagine they are riding the train doing some shopping. When the user departs San Francisco, they're connected to the San Francisco data center. They start adding some items to their shopping cart and writing to the database. As the train moves south, it gets closer to San Jose, and by the time the train nears Palo Alto, about the middle point, it may connect to either data center at any given time based on network conditions. The data may end up partially in San Francisco and partially in San Jose. No one data center has a true view of the data, but your customer will expect their shopping cart to be seamless. Active-active solves this with CRDTs. CRDT stands for Conflict-Free Replicated Data Type. Redis Enterprise can resolve differences between data located in two or more data centers. This can be achieved because Redis has a context to the type of data being stored at each key due to the integral types built right into Redis. In this case, we can represent our shopping cart as a Redis set type. Because of the properties of the set are well known, the logic behind resolving the conflicts can be easily applied consistently. Let's do a small demo. Redis Enterprise is running on a Docker container in my local machine, but we can illustrate the problem and the solution. I've built a small application that represents this problem. On the left, we are connected to a cluster that represents the San Francisco data center. On the right, we are connected to the San Jose data center. Right now, these two Redis Enterprise clusters are connected through active-active replication. If I add an item to San Francisco, we can see that it's automatically replicated to San Jose. The reverse is also true. It's not magical as there's no conflicts at this point. Now I'm going to break the network connection between the two clusters. Okay, now because each side is connected to the cluster separately, our data is no longer automatically in sync. When I remove an item from one side, it isn't automatically updated on the other side. Likewise, if I add an item on this side, it doesn't appear on the other side. The two shopping carts are quite different. If you just take the last right wins approach, you'll absolutely lose data, and the end user will think your application is broken. That's no good. So, you have to have a way to resolve these conflicts. Let's restore the link and see what happens. Okay, now you can see the items have been resolved correctly. The application that I'm using doesn't have to deploy any special code to reason through these resolutions. This occurs automatically and at the database level. This shopping cart example is only one of the many potential applications of CRDTs. Active-active can be used to power geo-replicated session stores, metering, counting, and queues, as well as many more. Active-active and CRDTs are only available in Redis Enterprise. If you have more questions about CRDTs or active-active, please contact expert@redislabs.com.